Hello students, welcome to my channel Pratima's Rasayana, and this is Pratima ma'am. Today I'm going to start with a new chapter in organic chemistry. Let's begin with some basic principles and techniques. But before this, I would like to tell organic chemistry is nothing but it's a branch of chemistry which studies carbon and different forms of carbon, all the compounds which are formed by carbon. Let's begin. I think you have heard in your class about catenation. Yes? So what is this catenation? Catenation is something related to carbon. Let's begin. So catenation is property of carbon itself. You know, carbon has got this unique nature to form bonds with other carbons and also with other elements like hydrogen, nitrogen, oxygen, halogens, etc. Right? So one carbon can form bond with another carbon. Then further more carbons are added and it forms a carbon chain. So this property of carbon is called as catenation. Carbon also forms bonds with other elements like hydrogen. You have seen many compounds where there is carbon as well as hydrogen which are attached to each other with certain bonds. So carbon usually forms covalent bonds. So in organic chemistry you will see carbons forming covalent bonds with each other, okay, where there is mutual sharing of electron. Now what is this mutual sharing and all that you will be learning in upcoming classes. You know, carbon, since it has this important property called as catenation, it can form various organic compounds, and these organic compounds have a vast use. Organic compounds are present in fuels, they are present in the dyes which are used for dyeing the clothes or for coloring the clothes. Then they are used in the manufacture of drugs. So the drugs which are available contain organic compounds. You have the use of, you can say carbon forms the basis of the genetic material DNA. So the DNA, proteins, all which are important for life is made up of carbon. Then you also find these organic compounds in polymer industry. The polymers are made up of organic compounds. You also have it in the manufacture of clothes. The fibers which are used in the cloth industry or in the textile industry are made up of organic. Next, we are going to learn about tetravalency of carbon. Oh, one second. Do you mean that carbon is tetravalent? What do you mean by tetravalent? First, the word tetra. Tetra means 4. Valent refers to valency. Let's begin with this concept. I think you have studied about the electronic configuration of carbon in your high school. So let's just brush it off. Carbon, its atomic number is 6. So that means it has got 6 electrons. Right? So let's write the electronic configuration of carbon. 1s2, 2s2, 2p2. So therefore 2 electrons in its s orbital, another 2 electrons in its s orbital, the last 2 electrons in its p orbital. So I'll just draw the orbitals here. So this is how you represent the orbitals in chemistry. So in s orbital, maximum 2 electrons can be present. So these are the 2 electrons which I'll be representing like this. Now with 2 half arrows, then you have the next 2 electrons will be inside this orbital. Now p orbital, you know, maximum it can accommodate 6 electrons, but right now carbon has got only 2 electrons. So I will just first fill these 2 electrons singly. So in the first orbital you will have 1 electron and the second electron will go into the next orbital. Okay, why this happens you'll be learning it in a different class. Now, so here the outermost electrons, now this is the second shell, this is your first shell, first main shell, and this is your second main shell. In your first main shell only you have 2 electrons which are in s orbital. Now in the second shell you have totally 4 electrons. So in the s orbital you have 2 electrons, and in the p orbital you have 2 electrons. So altogether 2 plus 2, 4 electrons. So these 4 electrons are called as valence electrons or outer shell electrons. So these valence electrons are going to participate in the bond formation. So these valence electrons or the outer shell electrons are going to participate in the bond formation. That is, these electrons are only going to form bonds with the other atoms or with carbon atoms. Now let me show you. For example, let's take, you have studied one important example, that is methane. So this is the structure of methane. Now here the carbon is in the center and there are 4 hydrogens surrounding this carbon. So now we call, since carbon forms 4 bonds with the other atoms, here example with hydrogen atoms, carbon is called as tetravalent because it forms 4 bonds with other atoms. Now these electrons, those 4 electrons or the valence electrons, I am going to show you. So here there will be one, this will be 1 electron of carbon, then this is the 3rd electron of carbon, and then here will be the 4th electron of carbon. So therefore 4 electrons of this carbon will participate in the bond formation with the other atoms. So carbon wants to form a stable bond, okay, and it wants to get its octet configuration. That is, altogether it wants 8 electrons to form a bond, right? So there will be sharing of these electrons of the carbon atom with the other atoms. So hydrogen has got its 1 electron, you know, it is 1s1. So this 1 electron of this hydrogen atom, this 1 electron of this hydrogen atom, then this 1 electron of this hydrogen atom, and this 1 electron of this hydrogen atom is going to form a bond. So therefore carbon is going to share its 4 electrons with the neighboring atoms to form a covalent bond. So there will be sharing. Okay. So in your class, when you have your friends around and you sit for lunch, what do you do? So you share your food with each other, right? So this is how sharing of electrons happens between carbon and other atoms or the carbon itself to form bonds. So this sharing of electron, the bond which is formed by the sharing of electron, is called as covalent bonds, and covalent bonds are very strong in nature. So this was about the tetravalency of carbon, or why carbon is tetravalent in nature. So this, using this important foundation, we are going to learn more concepts in organic chemistry. Thank you.